Book, Part 8, The Philosophy of the Ananke by Lance Gordon. You can again get a copy of my book directly from the information below this YouTube video. That is up to you, or you can listen to it. Let us continue where we left off on Part 7. So we're in Part 8 right now, page 44 or thereabouts. Okay, in fact it is page 49, looking at the thing. In order for Ananke's patterns to be true, they must manifest themselves in human nature as well as particle behavior. Consequently, the major universal laws that describe physical phenomena should have analogies between and within the disciplines that are not coincidental. In other words, we would expect to find analogous equations between linear motion versus circular motion, and between mechanical motion versus electromagnetic processes. In fact, we would expect to find similarities at the higher levels of generalities between chemistry, physics, geology, biology, and the like. Moreover, if the Ananke concept is correct, then all of the sciences should culminate in the four primary patterns. Not only would this be true, but analogies between scientific generalities and human behavior would become apparent as well. This is exactly the case. Ananke appears in all of the technical schools of thought. The tendency towards equilibrium, the constant change, the opposing forces that bring the particles back into balance in a most efficient manner are all present. To demonstrate this point, it'll be necessary to delve into the scientific disciplines. Let us begin our investigation with the world of physics, which had its origin in the minds of the ancient Greeks 2,600 years ago. Also, many concepts I deliver in this chapter 4 of dealing with the formula of Ananke and scientific law are necessary to understand in order to do the metaphysical speculation, which is the subject matter of number 5, chapter 5. Less valid in chapter 5 than these are, but nonetheless we have to draw the analogies to get to understand some metaphysical concepts. So when you're reading it or listening to it, pay attention a bit. We may need those concepts later on. Ananke and physics. Physics is the study of particle behavior. It includes the motion of the heavenly bodies, the motion of matter and energy here on Earth, and the electrical, nuclear, mechanical motion of the atomic particles. It is built on the faith that the change around us is governed by universal law and not the whim of time or space. That is to say, the laws are assumed to be unconditionally consistent. If found, they are assumed to be applicable in the past, present, future, and in outer and inner space. The physicist's quest is to find this law so that particular events can be viewed as mere subsets of the general condition. If these laws were probabilistic, then they could be described as guiding constraints. If these laws were deterministic, then they could be described in the form of exact equations. These equations could be manipulated by the logic of mathematics. If the postulates and assumptions were correct, and if the form of the equations approximated the, quote, real law to a sufficient degree, then new equations and laws could be found without the need of observation. These new laws could be viewed as educated hypotheses that would have to be verified by experimentation and observation before being accepted by the physics community. Amazingly enough, this process has served mankind well. Many new laws have been found by mathematics alone. If the conditions are reflected accurately in the equations, then the universe is found to obey mathematical law. The logos of Ananke is upheld. The universe has been found to be logical. Newton's first law of motion. In 1686, some of the laws of classical physics were published. In the Principia Mathematica Philosophiae Naturalis by Isaac Newton. By observation and experimentation, he found the law of inertia. Quote, every body persists in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. In other words, a body at rest tends to stay at rest, while a body having uniform motion tends to remain in motion, in that motion. In outer space, a body at rest or in equilibrium will tend to remain in equilibrium. This equilibrium could be a condition of no motion, as compared with some reference frame, or could be a condition of uniform motion, such as velocity. Rest is equilibrium. Uniform speed is equilibrium. Excuse me for a second. Oops. Hello?
Hi, Liz. It's Eunice.
Can I call you back? I'm in the middle of recording something.
Okay.
Okay, bye-bye.
Bye.
Well, that was an interruption I was afraid to happen one of these days. In other words, a body at rest tends to stay at rest, while a body having uniform motion tends to remain in motion. In outer space, a body at rest or in equilibrium will tend to remain in equilibrium. This equilibrium could be a condition of no motion as compared with some reference frame, or could be a condition of uniform motion, such as velocity. Rest is equilibrium. Uniform speed is equilibrium. They have no forces acting upon them. They cannot change their direction or state of rest by the whim of time or space. They can only change due to a reason, a force. Something must cause them to change. Causation is the rule and not the exception. An extension to this inertia law could be considered the property that equilibrium systems tend to stay in equilibrium as long as the opposing forces remain in balance. An example of this dynamic equilibrium, as it is called, is the state of uniform rotational motion. A satellite that orbits a planet will remain in orbit until it is compelled to change that state by forces impressed upon it, and it does not require any more energy. It takes no energy to remain in orbit, just the opposition of equal forces, in this case the inertia of linear motion and the force of gravity. Thus, once an orbit is achieved, things will remain in that state of balance. Orbits are very stable phenomena. Not only do inertia and gravity hold it together, but the angular momentum creates a further resistance to disruption, as in the case of a top or anything like that, where you find it's hard for it to fall over. What I say here is, it is hard to balance on a bicycle when the tires are not spinning. When the tires rotate, the angular momentum produces a condition of enormous stability despite the minor tilting that we may do. Thus, particles in heavenly bodies could achieve equilibrium if they only rotated around each other. They do. They tend to seek this dynamic equilibrium condition and remain in that state of affairs for a very long time. This is still the primary law of Ananke, the tendency towards the equilibrium between all things. But what is causing the particles to get into balance? What forces are involved? Why do these cohesive forces, cohesive meaning bringing together, forces exist? Why do they exist? Why not let everything explode into a chaotically diffused gaseous state, a state of entropy, what is called entropy, useless energy? Why must order prevail? That's the question. Newton's second law of motion. Newton's second law attempted to answer some of these questions by describing the property of some of the opposing forces in the universe. He only started the quest. There are still more questions than there are answers. He found that all moving objects had properties of velocity and acceleration. Acceleration occurred when an object increased its speed. Deceleration, negative acceleration, occurred when an object reduced its speed. He concluded from experimentation that the concept of force that could change the state of another object was related to the concept of acceleration and deceleration. Forces did not exist when an object was at rest or was in a state of linear velocity. It depended on acceleration, change in velocity. Not only was acceleration important, but a strange property called mass was involved. Given the same acceleration, a large metal ball supplied more force than a small metal ball. So force is proportional to a property of matter called mass and another property called acceleration. Through experimentation, he determined that the relationship was multiplicative. He found that force equaled mass times acceleration for all the objects in the universe. If we knew the mass of an object and it changed its speed or direction by some external event, then we could predict its new potential force with respect to another moving object. However, its mass would remain invariant, unchanging. The mass of many objects have been determined. For example, the mass of the Sun is 330,000 Earths. The mass of the Earth is 80 moons. The mass of the Moon is, I can't even pronounce this, let me see, billions, millions, billions, trillions, what's the thousand? It's an enormous thing. It's 162 and 1, 2, 3, 6, 9, 12, 15, 18, 21 zeros, and that's how many pounds the mass of a moon is. So you get an idea of the mass of things in comparison. The mass of an atom's nucleus is 4,000 to 500,000 electrons. The mass of a proton is 1,800 electrons. And the mass of an electron, here we go again, is 1, 2, 3, 6, 9, 12, 15, 18, 24, oh God, 27, probably 30 zeros, and then a 2 0. So it's 0.30 zeros and a 2 0 of a pound. It's extremely small, almost negligible, and sometimes appears more of a cloud than it is a particle. One last point should be mentioned. Curiously, many of the dominant forces of the macro world, that's the large world, have the same equational form as those dominant forces in the micro world. An example will enlighten us. The force of gravity is proportional to the masses in question, and inversely proportional, that means divided by, proportional to the square of the distance between them. On the other hand, the electrical force is proportional to the charges of the masses in question, and inversely proportional to the square of the distance between them. The format is the same, only the names and descriptions change. When all is said and done, these forces act in the same way given their respective environments. So the forces at work in our universe have similar forms of expression. Therefore, interactions between particles should have similar steady-state solutions in their respective domains. The macro world should produce similar configurations to the micro world. For example, the equilibrium condition called the solar system has planets revolving around a central star. On the other hand, the equilibrium condition called the atom has electrons revolving around a central nucleus. Moreover, the mass relationships between the parts of the system are curiously similar. That is to say, a star is to its satellite a planet, as a nucleus is to its satellite an electron. The mass ratios are of the same approximate magnitude. It's still a wide range. It's 4,000 to 500,000 range. But it's still within reason to say there's some similarity going on. Perhaps the forces are expressions of a common equational ancestor. Perhaps these equational ancestors are merely expressions of the four-pattern formula of Ananke. Perhaps they emerge out of necessity in order to oppose the statistical tendency for disorder and entropy. Perhaps these similar opposing forces are necessary in order to bring the disorder back to peace and balance for all. Newton's third law of motion. Before we can comprehend the third law, we must define certain fundamental concepts. Like acceleration and mass, energy is another property of matter. It can be transformed into motion, potential motion, or mass itself. It can be transferred between the objects in the universe in various ways. Kinetic energy is the energy of matter that is transmitted by virtue of its mass and speed. A large body moving at a high speed has more energy than a smaller body moving at a lower speed. On the other hand, potential energy is the energy of matter that is not due to its motion. That is to say, its position can determine its energy, as in the height above a floor. Objects can do more damage when they are dropped at 100 feet than at 2 feet. An arrow that is held taut on its bow, ready to be released, has potential energy as well. Lastly, mass is convertible into energy. Therefore, we can view it as potential energy. And one thing I was corrected by a physicist, I have as in the case of gasoline, but there might be some matter being transferred, but that's due to some other processes that deliver the energy. But the nuclear bomb is certainly, you have potential energy in matter being converted into the A bomb and the H bomb. In the light of the above concepts, we can now talk about Newton's third law. As is stated, quote, "To every action there is always opposed an equal reaction." Or, the mutual actions of two bodies upon each other are always equal and directed to contrary parts. In other words, for every action in the universe, for every force that is applied to a given body, there is an equal and opposite reaction. This essentially states the property of equal consequence in the universe. Every action will have an equal and opposite reaction in the cosmos. An object that is acting against another object will produce a transfer of energy that is proportional to the, quote, pain inflicted. I'm saying pain in quotes because I'm trying to use an analogy of saying there's that thing in people affairs too. The second object may be smaller and consequently move faster, or larger and consequently move slower, but the energy will be transferred and conserved. Energy is not created nor destroyed, it is merely moved around. The total energy of a closed system, what's called in physics a closed system, remains constant as long as no energy escapes to the external environment. If energy escapes, it is no longer a closed system, it's an open system, and the law changes. This also implies that an object is inflicting disruption on another object in a closed system ends up losing energy. The second object obtains that energy and can use it against the first, as in the case of billiards or, here we go again, quote-unquote revenge in human affairs. Similar. Consequently, when moving particles interact, they tend toward an equal transfer of energy over all the particles in question. Thus, equilibrium and the equality of motion prevails eventually. An example will help us. Take the case of a volume of gaseous smoke, that is made up of 2 billion tiny unique particles. They are moving through a 12-inch plastic pipe. Initially, let us say that 30% were moving at twice the speed of the other 70%. Through collision and transfer of energy, this injustice, as I'm saying it, even though it's quote-unquote here, would be eliminated. Eventually, given enough time, this, quote, race of particles would achieve uniform speed for the most part. A small percentage would always be a little slower, and another small percentage would always be a little faster due to chance occurrences. However, equality of motion would prevail for 90% of the group in question. Dynamic equilibrium would be achieved. The balance of opposing forces to produce a steady-state picture would prevail. This is still the formula of the Ananke. Now here's an important property in physics that we will use definitely in Chapter 5, the property of resonance. So pay attention. At this point in our discussion, we have become aware of the role of some of the forces in our universe. Forces exist in order to govern the behavior of particles. Not only do they exist, but they seem to have purpose and are therefore coordinated. They seem to be necessary. The forces of inertia, gravity, electricity, nuclear bonding, and the like produce an opposing, quote, creative, cohesive tendency to the physical universe. Cohesive meaning it pulls things in, creative meaning it creates things like the orbits and the like. And there's a tendency to do this. These forces oppose the destructive tendencies of diffusion, chaos, disorder with its resulting useless energy called entropy. Without the cohesive forces, the universe would have exploded into a chaotic mass of randomly moving dust forever. By statistical chance alone, the particles of debris would chaotically scatter to every point in space. The particles would never form orbits, nor would cooling occur, nor would heating take place upon condensation. Gravity would not exist. Stars, planets, and moons would never form. Night and day would have no meaning. There would be no light nor any logic to the word darkness. Life could never have emerged in time. A thin layer of eternally moving ash would occupy space and would exist in that state eternally. That would have been the fate of the Big Bang if it wasn't for these cohesive forces. Fortunately, this is not the truth. Cohesive forces do exist. They form stars, planets, moons, galaxies, and the like. They condense and heat objects. Light is formed. Darkness has meaning, and the cosmos becomes capable of creating life. The universe is not expanding by chance alone. It is law, the coordinated forces that rules the universe, and not the whim of time and space. The Greeks were right. The universe obeys law and not the whim of the chaotic gods. Are there other common behaviors other than these strange forces? Do other phenomena exist in common among the elemental domains of the world of physics? Might we learn an analogy to human affairs if we could study other physics generalities? The answer is yes, at least in my opinion. As an example that we will use later, we shall now discuss the property of all matter called resonance. Every uniform object in the universe has a natural frequency that it will respond to. That is to say, energy that oscillates at a given frequency will be absorbed by a neighboring object that has the same natural frequency. All objects not of that frequency will ignore the transmitted energy. An example will be helpful. Let us imagine 100 different tuning forks. If you've ever heard of it, it's a fork made of metal that you bring like that and go ding at a certain note level. It depends on the shape of the thing. It's a U-shaped with a pointer on the side so you can bling it on something, on a desk. Anyway, let us imagine 100 different tuning forks, each capable of producing a different musical note. Tuning fork number 1, when struck, oscillates at its natural frequency, the musical note of F. Tuning fork number 2, when struck, oscillates at D flat. Fork number 7, the note of C, and so on. All 100 forks are suspended in a container or room that allows no energy to escape. It is therefore a closed system. We introduce tuning fork number 101. We strike it, thereby producing the note of, let us say, C. The energy from this vibration scatters throughout the container, bouncing off the internal walls. The 100 remaining objects hear, so to speak, the vibrations, but they merely reflect the energy except for fork number 7. Fork number 7 has a natural frequency of the musical note C. It starts to absorb the energy. It not only hears the energy, it feels it. Slowly but surely it begins to oscillate in conjunction with number 101. It begins to vibrate stronger and stronger. It begins to resonate. If we had removed number 101, if we could have killed it, quote unquote, then the energy from number 101 would have been transmitted uniquely to number 7, not the other 99. Energy cannot be destroyed in a closed system. It can only be transmitted in space, and in this particular way, transmitted uniquely to a particular object that had the same natural frequency. Resonance is very real. It occurs in mechanical motion, in electrical behavior, and in nuclear phenomena. It can destroy bridges, as in the case of the Tacoma Narrows Bridge disaster of 1940. Just Google it and you'll see that dramatic effect of a bridge that was resonated by winds and absolutely swung it and broke it apart. It's really quite amazing. So you can look it up, Tacoma Narrows Bridge disaster of 1940. Tacoma Narrows, Narrows, Bridge as in bridge, disaster of 1940. It is indeed a universal property of all the particles in nature. But what about human affairs? Are there analogies that we can draw? Do we experience a form of resonance in our daily lives? Perhaps we do. Perhaps the feeling of like or love that occurs in a short meeting with another individual is a form of resonance. Our set of needs are unique to us. They vary in type and magnitude. This unique need configuration may interact quickly with another's. Personalities may click, quote unquote. They start feeding off of one another. In an hour, the feeling of like may grow to an unusually high level. Gestures, expressions, words, tones, and touch start to vibrate our psyches. The resonating information is being absorbed like a sponge. We begin to feel love. We become infatuated. In essence, the feeling of infatuation may be the result of our natural frequencies, our natural need configurations being stimulated. In essence, our feelings are shouting the message that this person may be a fit. This person may be able to satisfy my needs and get me back to balance, to equilibrium again. At least they seem to fit right now. If the need configurations do not change, maybe the love feeling will remain. So resonance can be considered a universal mechanism that enables energy, or perhaps information, to be transferred in a logical manner. Bodies of a kind generate similar natural frequencies when disturbed. These energy vibrations seek objects of a similar nature. Particles of certain natural frequencies will accept only certain sources of vibrational energy. Like objects vibrate and transmit energy to like objects. Like bodies cause like bodies to react. Causation rules the behavior of energy exchange and not chance. This is still the Ananke. And I want to check where I am time-wise. This may be the end of this part. And we're at 25 minutes, so I will say that we'll stop here. And we're up to Ananke chemistry on page 54, if you're following along. And for right now, let me get to the camera thing. And I bid you farewell temporarily until we get to the next part. Take care.